recognize the squirrel. And it looks quite nice. So it says, yeah, okay, the snout, if that's a squirrel, that's pretty good. And now, maybe I trained it to that extent that it only sees squirrels. That's why I'm using the cat bonkers of my friend. And it still works. Egyptian cat, it's so true, it's a Bengal. But you see, this is the part that it actually uses to recognize this as a cat. So it works quite well. We're not quite through. So it's not flawless, because this is like a real comic thing. It doesn't work. It thinks it's a comic book. Quite interesting. So work to do. And also this one, which is a rat or a mouse, and you would say, takes it for a fox squirrel, and then a nipple. So, I'm not quite sure. I think it's this part. Yeah, I'm just showing results, so sorry. And now, finally, so I've one more thing, which yesterday I got my login for the daily thing, so I entered a chubby green squirrel on the moon, and here it goes. This is what comes up, and also this one, which is quite nice. I tried it, and I think this is hourglass, so it really doesn't work, but that's also very hard. And there's things to do to improve it. I'm not going to go into detail because I just have 15 seconds left. And I posted the slides on Twitter, and I also have the notebook which generates this, so you trust me. And I have to say this was 27 slides, so you have to beat that. Thank you so much.
Between large groups of people, and this was just a cool way to try this out. So if you have some time, just go visit Condostore, try building an environment and trying out MB Condostore kernels yourself. Thanks.
You hear me? Excellent. Thank you, Chris. Really excited to hear about that. Instead of SAS, now we have JCAS. Did I get that acronym right? I'm still working on it.
I just want to let all of you know that there are live polls happening in the Lightning Talk Slack channel. I encourage all of you to participate. These are very important. We're going to use them. Lots of data analysis. It's for science. Yeah, data science, Python science, scientific Python science. Anyway, you should respond to them. Yeah.
Results from all polls will be put into a container and then sent in a satellite to...
With queso.
Yeah, am I still talking? With queso.
Yeah.
Okay, we're going to let Zach take it away. Gwen, are you out there? Yes, Gwen, you're on deck.
All right, thanks everyone. It's been so long since I spoke to you last. I'm here to tell you this time that machine learning is basically a natural science. In machine learning, we do a lot of experiments, we ground them with math, and then we discover things about how the world works. So my name again is Zach Hatfield-Dodds, and I work at Anthropic, where we write a ton of Python code. Anthropic is a public benefit corporation dedicated to building reliable, interpretable, and steerable machine learning systems. And that is what we call an open problem. So we do ML research, engineering, ops, policy, and of course, we're hiring like everyone else. So let's talk about large language models, which are super hot right now. One reason is that you can draw straight lines on log-log plots, which I understand is very popular with a range of scientific disciplines. In this case, what we see is that as we make models larger, as we spend more compute training them, we increase the size of the data set and we increase the size of the model, we get this very, very smooth and predictable improvement in our ability to predict the next token. But what we get is an unpredictable and quite sharp improvement in the model's ability to do things like arithmetic, or writing Python code, or answering natural language questions. And this is going on to the point where benchmarks are saturating increasingly quickly. In the recent case of Big Bench by Google, the benchmark exceeded human performance before the paper could be published, which seems a little unfair. And that might be why, despite the cost, which is in the millions of dollars, an increasing number of people are training these. We call them foundation models because you can use them to build all kinds of other things. Mathematics, it's a thing in natural science and also, believe it or not, in machine learning. As a quick refresher or introduction for those who don't know, all modern large language models are what we call transformers. At the start, you take your one hot vector saying which word you have and you project it into the model space. Then you have a series of layers which do matrix multipliers to work out where it should look for each token, followed by pointwise nonlinearities, which we call neurons for historical reasons. And then at the end, you get a probability distribution over the token. Because they're all matrix multipliers, you can chain them together because they compose really nicely. So you can read and write to subspaces of this residual stream, move information around, copy it, or invert it, so that adding that back deletes it. The neurons themselves represent the features. Because we're doing matrix multipliers, most of them are non-privileged, in a non-privileged basis, so it doesn't really make sense to think about the whatever neuron. Instead, neurons are sort of represented sparsely as a compressed version, as in compressed sensing, of a much larger, sparser network. One of Anthropic's specialties is interpreting the lower level mechanisms that these models learn. And the one that I want to highlight to you from our papers is the thing where models learn induction. It turns out that you can not only learn inductively, but you can learn to do induction just by looking at enough data. In this case, what we see is that when you give the model longer chunks of text, it's better at predicting what is going on. Because if it sees A, B, C before, and then it sees A, B, once you get more than one layer, you need at least 2 layers for this, you can realize that if you've seen A, B, C before and you've just seen A, B, the next thing is probably going to be C again. And we can actually watch the particular parts of the neural network which learn to do this form over the course of training and trace that through into the change in training dynamics at the grossest of scales. So, my argument that machine learning is a natural science is that it involves a lot of calculus and linear algebra. It involves doing experiments. It involves building large instruments in a way which physicists and astronomers and natural scientists are much more used to than computer scientists tend to be. So in summary, I have the coolest job in the world, and you could too. Come join us. Thank you very much.
Very nice. I think I'm convinced that machine learning is a natural science. For me, it's because I have my experiments fail a lot when I'm doing machine learning models.
Okay, there's that too.
Yes, thank you. I just wanted some recognition. Gwen is going to take it away, and we're going to have Javi, Happy Web Apps for Data. Are you with us? Yeah, there you are. I'm back. You're on deck. Gwen, you have 5 minutes to explain all of quantum physics, and you should have a dog gif in there, too.
All right. I'm going to be really lazy and say nobody understands quantum physics. So I'm going to be talking about quantum in the cloud, and it's going to be enlightening, hopefully. I first want to say quantum hardware is really cool. It's very, very cool because we're at near 0 temperatures. I'll wait for that to land. And we're here at, this is a dilution refrigerator. It cycles helium, a mixture of helium-4 and helium-3. And by thermodynamics and other kinds of magic, this gets close to like 10 millikelvin. And the kind of stuff we're measuring here is quantum states. So again, I'm not going to explain all of quantum mechanics, because what the heck do I know? But it's all very cool. There's electrons, there's photons, there's lasers. In our case, just very, very cold electrons that we can manipulate individually. And really what I wanted to share with you all, in case you didn't know already, if you haven't seen any other of my talks, you can now use quantum hardware in the cloud. So that's really cool. These are the kinds of systems you can use. I mentioned lasers already. There's trapped ion computing systems by IonQ, by Quantinuum, that you can access through Microsoft Azure. So advertisement, we're a sponsor. Come visit us at our booth. I wanted to do a really quick demo because, yeah, I'm kind of edgy like that. So I basically just ran this code, and I really want to say these are really quantum systems, and you know, a lot of people are quantum skeptics. I talked to a few, you know who you are, and you can say like quantum is hypey, quantum is not yet that useful, we can't really have a speed up yet, but that's okay because quantum is really, really cool, and not in the sense of 10 millikelvin, but it's actual quantum mechanics you can play around with, And I wanted to talk about, you can actually do a Robbie experiment on a real quantum processor. And normally you can only do that if you spent 10 years doing like a physics PhD and postdoc and whatnot and have exclusive access to like a dilution refrigerator in a lab. You can now do that at home. So if you know what a Robbie experiment is, it was originally an experiment you would do with an atom in a magnetic field that would just rotate. Here we're talking about a general two-level system that's going to rotate in phase space between 0 and 1. And here I'm using a language called Q#. Please come talk to us at the booth if you want to learn more about Q#. It's a domain-specific language where quantum is a first-class citizen. You can use it from Python, so that's what I'm using here. We've got this really, really cool %% Q# magic where you can just literally directly code Q# in Jupyter. I'm not going to explain what Robbie is. I would encourage you to try it out, but I literally just submitted this, so fingers crossed that it succeeded. And if it failed, I have a backup. Oh, it succeeded. Great. So what I'm doing here is I have one job for each coordinate, x, y, and z. And each going to give me a job ID back. So that's really how it works. You send it a quantum program. That's what we call a job. That's kind of what Azure's bread and butter is. Ironically, jobs. And so we oh, too soon. Maybe. Okay, and that's going to give me a vector in Cartesian. And then I'm going to use this really cool package called Qtip, which we had some swag of Qtip on our booth. We might have some more tomorrow. Qtip is another quantum package. And yeah, I can plot on the block sphere. I can plot a qubit state. So this is really generated. Here I used the simulator, so I kind of cheated because it takes a while for a QPU to return results. But yeah, I can do an actual quantum experiment in the cloud, on Azure. So come talk to us if you want to try it out. I just want to say how cool that is. And I don't care if there's no speed up. I think it's awesome. So thank you all so much. I just wanted to highlight that we're one Microsoft, so this is not just a quantum booth. There's other folks from Microsoft here. We've got Sarah Kaiser, who's a senior cloud developer advocate for Python. Talk to her about stuff like Azure ML, VS Code, data science workflows on Microsoft products. And then Andreas Müller is a research SDE. And talk to him about, we're looking into supporting open source from Microsoft and PyData ecosystem. I believe Andreas is giving a lightning talk tomorrow, maybe. Fingers crossed. All right, that was me. I don't know if I went over time. No, 5 minutes. Awesome. Thanks, everybody.
Wow, Gwen, that talk was really cool.
You know, I'm into quantum computing, but I really would like to have some nuclear computing. Yeah.
You would.
Oh, no, I don't have a dongle.
Oh, you don't have a dongle?
No. Maybe someone can run.
You have to call the next person who doesn't have a dongle.
Okay. It's on deck.
Who's on
Yes. How about we're going to have Matt Rocklin on deck if you are out there somewhere. Matt. I bet he's staring furiously at his laptop in a hallway somewhere.
What is your, do you need USB-C? Who's after
Yes,
Rocklin?
after Matt, Mars,
Mars.
if you're ready. Yeah, go ahead.
Yeah, come on.
You're up.
Got a savior. You guys are awesome.
Sebastian, thank you, sir.
An extremely quantum help.
Yeah.
Yeah. Or cool? Oh.
He played it cool.
Ooh, much better.
Right. Hi, everyone. My name is Javier Luraski. I'm a software engineer that has been building tools for data science for quite some years. In the past, I worked with the R community, but now I'm here. Yay! Now, don't get too excited, because I'm going to explain you what I'm working on next. So while I was working on the R community and also building packages for Python and R, I got overly excited with JavaScript, which I don't know how many of you here are excited about JavaScript. Maybe, woo, there you go. Some of you are. Anyway, so I got overly excited while I was working with the R community on JavaScript, mostly because there's a lot of things that are coming along that look really promising to me. So for instance, now you can use TensorFlow.js on the browser, and that has been used, to create some self-driving car demos. It has been used for American Sign Language, interpreters, and also technologies like SpaceX are building their stuff with JavaScript, right? So to me, that felt like super, super interesting. So what I did is what any reasonable person would do when you find a new cool technology. You quit your job and you spend your time looking at it. No, don't do that anyways. What I spent the last year was mostly looking at what can we do with JavaScript for data science, machine learning. And I actually found out that there's a lot of things that we can do. Sorry, this slide's a little bit cramped. But yeah, basically, like if you think about, some of the main use cases for JavaScript, right, would be something like the New York Times wants to do, like a visualization. So, like you use it, right? And you use it there. And there's other tools, to do data transformation, like Arcaro.js, Danfo, Tidy.js, etc. So we kind of like myself and a few friends got together to figure out what we can do in this space. But what we realized is that we all love Python, and it's really hard to convince people to do JavaScript, right? And with good reason, the Python community is awesome and it's quite big, right? So instead, what we try to do is, we try to take a look at where can we apply, technologies like JavaScript in the Python space, and how would that look like? And what we realize is that today, when you build a web application, most web applications today are built with a client-server architecture, right? So whenever you click a slider or you move something around, if you're using Dask or Streamlit, whenever you move a slider, you need to go to the server, change some data, and then come back with the results. And that makes the apps a little bit slow, right? Because everything needs to go to the server. Obviously, we can get away with that completely, but we figure out that maybe we can apply JavaScript for building web applications better. And that's kind of like what we've been up to. So we have an open source project. It's called HAL9AI/HAL9AI. And we have kind of like an interface that wraps JavaScript blocks into things that are usable from Python and that can run on the browser. So I'm going to try to do a quick demo here and give a few details. So what I have here is a Jupyter notebook, with some of the code that, executes this particular project. Which, what we're doing is we're loading iris, we're adding a dropdown, we're adding a filter, and we're adding a scatter plot, right? And actually, this should be sample. So the idea here is that we're building a web application with JavaScript, but all from Python. This is early stage, early development, so don't get too excited. But if you want to help, we do have a GitHub project. So the idea is that now when you click sliders and things around, the application is pretty fast, and you can make it it's pretty responsive mostly because we're kind of interfacing between JavaScript and Python without having to write Python code, which is the advantage. So what would be the application? Well, the application of this would be something like, if you want to publish some static HTML, like a notebook, the idea is that you can publish components that are interactive. Again, and the way this is just plain HTML that we publish. It's on hal9.com/notebooks. It's quite broken, but you can go steal and visit it. And the idea here is that we have the same slider, and we're filtering or doing some operations, and it's running on the browser. So I think what we can use your help with, if you're interested in JavaScript in general, we have an open source project. There is a star button over here. That's very important. I'll just leave that. But you can also help us with the scripts folder. There's a lot of JavaScript that we're wrapping into this, and there's also the R and Python code that we're working on that. And if you want to help us a little bit more, if you go to hal9.com, we have a survey that you can use. And thank you so much.
Perfect. Madigan, you were ready to take him out.
I was, but you got there you finished just in time.
That was close call.
Yeah.
First SciPy, first lightning talk. I don't know. That was pretty smooth. Mars, are you out there? We want to hear about comics. Yeah.
Yeah. I bet this is going to be out of this world.
Wait, I went over my head. We should have more queso jokes, I think.
Yeah?
Yeah, this should be cheesier. We really went all in on the queso branding this year, so yeah.
Who's on deck?
Who's on deck?
Yeah.
Oh, I thought we were doing like a who's on first routine. Sorry. So how about Rich? Awesome.
I thought you said that we were going to hear about comets, not comics, and then I saw comics up here, so my joke made sense to me. Sorry.
You could just do regular view.
Oh, yeah, see? Thank you, Paul. Yes, Paul saved me. Never mind. That was intentional. That was a great joke.
Paul, can you come up and say that on the mic so it also...
Oh, yeah, sorry.
It was also Mars.
Nice. I think we should let Mars talk for this.
Let's let Mars be a star. And who's next?
Do we have a Benoit? We're running out of people on the list. Y'all signed up.
Benoit talking about data maps.
Benoit's here. Benoit, you're on deck.
Benoit. Okay, great. And then after Benoit is Darhas. So just come sit next to Benoit. So we'll get 2 people up here.
Perfect. Mars, you can take it away.
Hello, hello, everyone. I am Mars Lee, and I am here bringing in the fun, the accessible, and the comics. So thank you so much for letting me speak. This is my first SciPy and first lightning talk. I didn't actually think I would get a talk today, but as you can see on your tables, there is some excitement building up, and we will get to there exactly to what that is. Ooh, did I? Okay, so you might have seen me earlier at the QuantSci table, or you might have seen it on Slack, that I have these comics of how to write alt text for scientific diagrams and documentation. So basically on the table, you get a comic, everyone gets a comic. Woo! And comics, as you know, are super duper fun, and they get to tell really fun, emotional stories. And we also like comics and memes that tell us about our daily lives. And then, of course, there's comics like this that we all know that kind of speak to our own work lives. And I wanted to create comics that could do all of that. That could be emotional, that could be stories, that could be work, and something that we can move forward with. So, a very brief introduction. I'm Mars. I'm a technical illustrator at QuantSci. And the inspiration for these comics are these workshops that I hosted in QuantSci Labs with my coworker, Isabella. And we've been hosting these alt text workshops. And in these workshops, you crowdsource adding alt text to images, hosting 1-hour sprints where people make contributions using the GitHub Suggestions feature. And these are the communities that we already made a real-world impact in. So what I wanted to do is scale up. In these workshops, usually have 10 to 20 people in a 1-hour workshop. But with these comics, I can reach 300 people over a course of 3 days. So again, these comics, they are attention-grabbing. As you can see, we have the hero or the superhero out in front. They are tactile. As you've seen throughout the day, something that you can hold, something that you could flip through. It's something that you can color. So these are actually pictures from Twitter that people have tagged me in because they really like it too. And it has a story. So this story over here is an example of the kind of conversations that I've had in the workshops and that I wanted to bring to everyone else, that these are really good questions that people are asking. And there's also humor and emotion and just how we react to the problems that we face and how we try to think of solutions. It's collaborative and tactile. So today or yesterday, I met Benoit about his zines, and it made me really happy to see other people wanting to create in this space. So I made some zines with him. It's also collaborative and tactile, as in you can get your friends to fold and staple for or with you. And you know, it's actually kind of foolish to go about it alone. I was up until like 4 a.m. trying to print this alone. I felt real sad. I felt like, oh, well, I put myself in this mess with this deadline, and I have to deliver. But I'm forgetting that I do have friends, I have coworkers, I have community, people that care for me, and that I can really make use of that. And so, you know, I bring more and more people in. And so now we have a whole party, and that's Rebecca, Tyler, Thomas, Rohit, Pamela. And, you know, the real treasure was the friends we made along the way. So lastly, these are interactive. So, of course, you can write in it. You can use crayons. It was also interactive in that we can go back to digital. You could scan the QR code and make a contribution. We have the 4 projects here if you want to make your contribution. And when you scan it, it leads you directly to the PR, so you could do that. And if you want a copy, there is a digital version that is posted in the general SciPy Slack. There is also the paper version you have on your tables here. I'll also be continuing to give them out at the Quan site table outside the ballroom. So here is a link, and as you can see, it's a digital flippable version. You want a copy, again, come to our table. It is a limited run. So once they're gone, they are gone. This is a drop, a release. And thank you so much. Before I go, I would like everyone to, maybe if they have the time, to scan this QR code, because I sure think it is something special. Thank you. Thank you.
Thank you. Never going to give you up. I think that was a mint condition.
I'm never going to give Mars up. I think you're hosting lightning talks in the future. Are you ready to roll? Rick roll?
Whoa.
No? Is there something there? No.
It's the year of Linux desktop.
Yeah. Nothing?
If you keep having trouble, we can move you. To a different operating system.
Yeah. Is it working?
No, it's not working. They're
Yeah, we tested this before. Of course.
the screen is an abyss.
All I need is a browser.
Oh, hooray! And then there was light.
Jeez. All right, so I'm going to talk to you about awesome her. Sorry? Move the mic? Is that good? Or hold the mic? No, I don't want to hold it. No. Okay. Yeah, I'm going to talk to you about awesome her. I'm Rich Signal. I'm a research oceanographer at the U.S. Geological Survey. I had some help on this from Martin Durant at Anaconda and Eskild Eriksson from Quansite. So the HER model is the best weather model that we have in the US. It's a 3-kilometer resolution model that updates every hour, and it simulates radar data every 15 minutes. So it's a pretty sweet model. If you go to the website, you see some static graphics like this, but all the data is uploaded to the Amazon Public Data Program, which is awesome, except that it's 4,000 GRIB2 files per day. So if you want to use it as a scientist, unless you love GRIB, you're wishing there was a better way. So I'm here to tell you there is a better way. What we've done is we've used a package called KerChunk and the awesome FS spec package to basically pull all the metadata out of these GRIB files, and then all that data is in JSON, and it points into, it has byte range, it does byte range requests into the GRIB files to pull out the blocks of data. So at that point, it's just blocks of compressed data. So at that point, it's as cloud optimized as you can be. And also, you don't need any of the native libraries anymore. So you don't need the NetCDF library, you don't need the GRIB library. You're just using the ZAR library to read the GRIB files. So it's pretty cool. I'll show you how it works. So basically, we're just going to import some packages here. Actually, I've already imported some packages and started a cluster, just, I hope, so that I didn't have to spin that up. But I'm just using a DAS gateway cluster here, but you could use, of course, whatever DAS cluster you want. Let's just make sure we have a cluster. Okay, yeah. So we've got our 30 workers and 60 threads. So here's this JSON file. It's just sitting out there on S3 in a public bucket. Okay, so I could show you how we created that with another Python script. But here I'm just going to show you us accessing it. We're going to use FS spec file system. It's a reference file system in FS spec land. So if we can load that up, and if we take a look at the file system, we can see that it just looks like a ZAR data set if you're used to looking at ZAR. So we can get a mapper and open it up in Xarray. So now we've got a data set. Let's just take a look at the data set. And there we have 90 time steps, which is what I've done just 3 days, and then the latest forecast I tacked on the end. So I took the forecast hour 1 from each of the hourly forecasts and then tacked on the latest 18-hour forecast. So there's 90 steps here. You can see all the variables. We just loaded the metadata, of course. So we can go ahead and like flip the coordinates around so that hvplot likes them, pick a variable, say, like, let's pick now to take a look at what's going on right now in the HER. We can use hvplot with quad mesh to pop this up. And so then we can use all the nice little tools in hvplot, like to zoom into, let's say, my favorite spot, the Great Lakes, and of course it'll refresh and update. You can see it's a really high resolution model. And now let's just go and, so that just pulled a single grid file, right, and rendered it. But now we're going to pull a time series from all the grid files at a specific spot, which is Austin. So you can see all the cluster light up, and that's how we get the massive throughput. We read all the grid files almost simultaneously with all the workers. So now you can look at the time series. You can see that tomorrow is going to be maybe a little bit cooler. I'm not sure what's going on with these dips here. They just got this working today. But the cool thing here is, that JSON is updating every hour through kbatch cron job, which is like a new thing. So if you go look at kbatch, so that's the way to submit batch jobs like notebooks to your Kubernetes cluster. So we have a Jupyter Hub running. You can use kbatch cron job. So it's updating this JSON every hour, and anybody can use that JSON. And as I said, you can use it with any DAS cluster. You don't need credentials. It's all public data. So yeah, that's it. Thanks very much.
Thank you, Rich. And now we have Benoit up. The question is, are we going to fit everybody in the hour? I think we are. I think we're going to make it. Oh, you thought I was going to have like a funny pun in between the talks? No, sorry. Take it away, Benoit.
You can taste the rainbow. I'm here to talk about methodology that my colleagues and I have been fielding, building up to slowly, called data mapping. And it all starts with us being called scientists, data scientists. Isn't it a little insecure way to describe ourselves? Like, astronomers don't talk of themselves as space scientists. Yet we do. It's also a little shifty, like, trust me, I'm a scientist. Okay, so what do data scientists do? Many things. We drink a lot of coffee, and sometimes we have to answer the difficult questions of people coming to us. Hey, scientist, I have a data. What can I do with it? Can you throw code at this? Can you throw an AI at this and will thereby solve my problem? So we have to figure out what a data set can help us doing, what insights we can derive from it. The typical approach for auditing a data set will start from a spreadsheet. You will open that up in Excel and do a pivot table and click on the arrows. Good data auditors will then take that to their favorite kit of choice, do some more experiments with it, but it is still a process that is very intuition-driven. Perhaps I can classify it that way. Perhaps I can format the data that way. There is no system to this madness. So here we are proposing a kind of a beginning of a system. Let's call that data mapping. It's a 4-step playbook. So first, you formulate a hypothesis about the structure of your data, about how the records of it come together, relate to each other, and embed it to vector space. Then you take those vector space, those vectors in this space down to 2 dimensions, and you Jackson Pollock it on a scatter plot. Perhaps you feel courageous and you run some clustering experiment at the high dimension vectors you have to get a sense of how your similarity assumptions work out. And from this initial annotation, you then go and interactively play with your data map and figure out how your assumptions hold up in reality, and annotate all this live, perhaps even producing labels as you go, perhaps realizing, oh no, my assumption doesn't hold. There is, however, another structure that I discover thereby and can articulate in a new iteration of the experiment. So we even have tools to do this right now. Nearly published library in Python we have been building called vectorizers to vectorize the data. We also rely on UMap for similarity-sensitive dimension reduction to a 2D space where if things come together in a Euclidean, Cartesian kind of way, it means they truly are related. We have HDB scan to do density-based clustering that works even in high dimension where everything is sparse. And we are working on this little bit of interactive play with the data map that's called This Not That, which is a name that I have chosen to confuse presenters forever henceforth. So we are fielding this methodology, playing with it at the office with data that our customers are coming with. It mostly works, but come speak to me if you have ideas about tools, about ways to strengthen this, and yeah, that's it. Thanks a lot for your attention.
Thank you, Benoit. It's always good to name your library to confuse presenters. If there's anything I've learned as an open source software developer.
I mean,
I'm serious, that's not a joke.
Why wouldn't you use your power to confuse people?
What? So that they can use a confusion matrix. Sorry.
I hear some sparse laughter.
All right, Darhas, we'll let you take it away.
Hey folks, my name's Darhas, and I sometimes do useful things. I work at QuantSite. But I actually want to talk about one thing which I think is useful. How many of you use time series in Panda? Okay, raise hands, okay. How many of you would hurt me if I said you are not allowed to use time series tools in Panda, you have to write your own? Okay. There is an entire community who has not been able to use time series code in Pandas since 2014. This is an open issue since 2014. Pandas a long time ago made a decision to use nanoseconds as the core resolution, and because of that, you can only represent times from 1678 AD to 2262 AD. And if you're in paleoclimatology, the Earth is a lot older than about 200 or 300 years. And they have not been able to use pandas for time series. They've been having to write their own code to do plotting, to do basic stuff that we all take for granted. The good news is the paleoclimatology community got an NSF grant, and they used that to actually finally fix this issue that's been open since 2014. So in the next version of Pandas, like actually 40,000 issues later, if you look, the previous thing was issue 7,307. Now we're at 46,587. And 2014 to now, that is like 8 years. So 8 years later and 40,000 issues later, in Pandas 1.5 that's releasing sometime soon, the prototype for non-nanosecond time series will be in master. If you guys want to experiment with it, try it out for any of your use cases. In Pandas 2.0, which is I think targeted at about 6 months out, I think around the new year, it will be in master. And if you want to discuss in the GitHub issue, there's a lot of complications with this. So in Pandas 2.0, you're going to have second, microsecond, millisecond, and nanosecond as optional choices inside Pandas. There's a GitHub issue tracking it. And the PIs for this project, Deborah and Julian from USC, were not able to be at the conference, but they are really interested in hearing from anyone in other communities who are not in paleoclimatology that might want to use this. They actually have other things we're going to be trying to help them build out. Once this lands in Pandas, they have negative time indices and other things we're going to be trying to help them with. So please find me at the Quantsite table or somewhere, or email these guys if you're a community that might use this feature, because they want to hear from other communities. And also for the NSF grant, they have to do the whole who does this impact stuff. So you guys know what NSF grants are like, so please help them with that as well. So non-nanosecond, it's possible, open source, 8 years and 40,000 issues later, we're closing an issue.
All I have to say is it's about time.
Okay, so that's all we have for lightning talks today. Now it's time for the poster session, I think, and Job fair. Yes, okay. So mingle, chat, talk about squirrels or other animals, you know, or time.
And yes, take your time and talk about squirrels. Also, you should just know that Julie, who's here, has prizes for the best lightning talks over all days.
Over all days.
So, you know, no pressure.
Imagine Lion King music playing right now as she holds that above everything the light touches.
And they fit in with the queso theme for this year, so just no spoilers, but be ready.
Okay, so. And so tomorrow, Lightning Talk sign up will be starting in the morning. We'll post a new sheet. So you can't sign up now. If you are a first time attendee or it would be your first Lightning Talk, please make sure to note that. We will apply our own weighting factors to the ordering. It's very scientific, so, you know, make sure you do it. And we'll see you tomorrow.
Yeah, see you all then. Thanks, everybody.